We are now on slide 7. So, examples of symbiotic relationships. Okay, mutualistic. So, in a mutualistic relationship, both animals benefit. Okay, and in slide 7, I give an example of a bee and a flower. Okay, so whether you know this or not, flowers actually evolved. Plants decided to evolve flowers. They made those flowers with bees in mind. Bees are one of the oldest living organisms on the planet. In terms of the insect world, they've been around as long as flowering plants have been on this earth. Bees have been around. They evolved together and they evolved to benefit each other, and they are both dependent upon one another. That's why bee populations are so important to the world's ecosystems. So the idea here is that the reason why a bee and a flower or a plant is a representation of mutualism is because both the bee and the flower will benefit in the relationship. The bee moves from flower to flower getting nectar, while the plant deposits pollen on the bee's legs to spread their seeds to other flowers. So when a bee goes up to a flower, it sticks its little snout out to go into the flower, and it pulls nectar. As it's standing on the flower, unbeknownst to the bee, the flower is putting little tiny pieces of pollen. As the bee moves around, it's picking up these little pollen pieces that are on the flower. Then the bee gets some nectar there, the nectar's drained, then it moves on to the next plant. And as it's sucking the flower up, depending on if the plant is male or female, it will then deposit the pollen into a different plant so that the flower will grow seeds. That is an example of a mutualistic relationship. The bee is getting nectar while the plant is able to spread its seed around to reproduce. Next example is commensalism. In commensalism, one animal benefits from the relationship, while the other animal, it doesn't benefit and it doesn't get any harm. Okay? The example I gave here was a bird and a hippo. It says a bird stands on the back of a hippo. And I know we've all seen the safari videos where those little birds are running around and hopping up on the hippo's backs. It says the weight of the bird obviously does not affect the hippo, yet the hippo is providing the birds with a sitting area to rest offshore and away from predators. One of the reasons why the birds sit over there, it could be because of the fact that the birds are away from predators, so they like to sit on the hippo's back. The other reason why is maybe they're fishing in the water and they're standing on the hippo's back, so they're at a good scope, good area for them to see small fish. Maybe they can pluck in and take a bite of a fish. But the idea here is that if a lizard hops on my back and I don't know it, or I know it, and he's trying to get to another destination, it'll take the lizard an hour for him to 2, 3, 8 days to walk from where I'm at to the front of my neighborhood, whereas it takes me 5 minutes. If he hops on my back, it doesn't bother me at all. Like, it doesn't hurt me, it doesn't harm me. I just have a lizard on my back. But for him, he greatly benefits because it's not going to take him all that time to reach the area where he's trying to go. So the idea here is that is an example of commensalism. And then the last one that we have is parasitism. And this is where we have that term parasite. Parasitism. On a dog, the best example is a tick and a dog. A tick forces its appendages, into the dog's hide to suck its blood while the dog is weakened with infection and blood loss. So we all know that ticks and dogs are associated with each other. That is a parasitic relationship. The tick is benefiting. It is feeding upon the dog's body. And in return, the dog is getting harmed. It's getting an infection in its skin. It's getting weakened by the infection because its body has to fight off all the harmful bacteria from ticks. Okay. And it's just simply put a parasitic relationship. We are now moving on to slide 8, and slide 8 is just basically showing you, interaction examples. If both faces are happy, then it's mutualism. Everybody wins. If one's happy and one's neutral, it's commensalism. One wins, one doesn't win and doesn't lose. And if it's parasitism, there's going to be a happy face and a frowning face. Why? Because one of them is benefiting greatly while the other is being significantly harmed. Okay. We are now moving on to slide 9, and so I gave you 3 basic examples of symbiotic relationships: mutualism, commensalism, and parasitism. There were also two other examples of animal relationships. These examples include both predator-prey relationships and competition. The slide reads, along with the three types of symbiotic relationships, there are two other relations that exist among organisms. In any given food web, there are two main types of general relationships: predation and competition. Okay, so the idea here, predation. Predation is when one animal hunts another for food. When we think of food chains, we think of one animal preying on another until the trophic level of producer, meaning that we know that in a food chain we have one animal eats this one eats this one, that one eats that one, and that one eats the plants, and the plants don't eat anything, they just get their energy from the sun. The concept here being that predation is when one animal eats another. The other one we have is competition. Competition is when animals are in competition for the same resources. If mountain lions and wolves both hunt deers, okay, and they're both tertiary consumers, then they are both in direct competition with each other for the same resource. That is competition. Okay, and I know we all know what competition is. We're both fighting for first place. We're fighting for the same thing. In the animal world, it's fighting for food and survival. We are now on slide 10. Food webs and animal populations. In any food web, the population of specific animal species in a given environment is directly associated with the trophic level. It says right here that trophic levels refer to the level at which a given species sits in a food chain. A grasshopper occupies the primary consumer trophic level, because it feeds off of vegetation. So trophic levels are just, if you're primary consumer, secondary consumer, tertiary consumers, those are all trophic levels. It's just the level that they occupy in the food chain. If I ask you, which trophic level does a squirrel occupy? Or which trophic level, let me say it this way, which trophic level does a plant occupy? Your answer would be producer. If I said, which trophic level does a squirrel occupy? Your answer would be primary consumer. The lower an organism sits in a food web, the more abundant an animal will be, or else a food web would not function. And this is very important. For example, when you step into a forest, the first thing that you are going to see is thousands of individual leaves from all the vegetation. Okay? If you examine all of those 1,000 leaves, you may notice some grasshoppers grazing around the leaves. For every 1,000 leaves, there are 100 grasshoppers. There's going to be more leaves than what there are grasshoppers, because if there was more grasshoppers than there were leaves, then the grasshoppers wouldn't survive and the leaves wouldn't survive. Okay? And then it says for every 100 grasshoppers you may find 10 lizards that eat grasshoppers. And for every 10 lizards that you may find one fox or one small mammal, like a small rodent or a rat that feeds on the lizards. You see what I'm saying? It's a balance. It's a balance. Okay, it's got homeostasis. There's a balance among food webs and food chains and things like that. Now, population continued. It says, although a mountain lion may hunt and eat deers, the deers indirectly depend upon mountain lions for survival. So how could a deer depend on a mountain lion to survive when the mountain lion hunts the deer? It almost seems paradoxical. Well, I'll explain that to you right now. Going back to what we learned on day one, I stated that animals in a food chain are dependent upon one another for survival. Mountain lions and other apex predators that feed on deer play an important role in controlling the deer population. If mountain lions went extinct, it would create a large population imbalance, which could significantly alter an entire ecosystem. Ecosystems are always changing but maintain a certain level of homeostasis or balance. The word homeostasis means balance, equilibrium. Okay? Deers feed on certain plants that other animals also feed on. Okay? If all mountain lions disappeared, then deer populations would dramatically increase. So if we eliminated all of the predators that eat deers, then those predators eat the deers. Now they're gone. Now there's going to be deers are all going to be in deer heaven. They're all going to be running around all over the place with nothing to worry about. That can create a problem. Okay. It says right here, if all mountain lions disappeared, then deer populations would dramatically increase. The plants they eat would disappear due to overheating, and other animals that feed and eat the same plants that the deers could eat over time could find themselves extinct. So let's go ahead and reflect on this. Mountain lions and other apex predators that feed on deer, they control the deer populations because they feed on them. So they create a balance. For every 100 deer, there's 10 mountain lions. Those 10 mountain lions on average eat 2 deers a week. So it keeps the deer population in balance. If all the mountain lions and all the predators that feed on deers disappear, you're going to have an abundance of deers. That means that whatever food that the deers eat, which likely other animals eat too, that food is going to start disappearing because the deers are all going to be eating them, and there's going to be no control, nothing to stop the overabundance of deers. Those plants could then become less and less scarce, at least the leaves could be. And then that could result in actual extinctions. And these are things that actually have happened before. So that was my way of trying to show you how these food chains are very much interconnected, how they are dependent, all the animals are dependent upon one another. That's why the lesson is titled Interdependence. Just because a mountain lion eats a deer doesn't mean that the mountain lion is 100% harmful for the deer. It's not, okay? It can be harmful in the predator-prey relation, but when you look at the larger aspects of food webs in a single ecosystem, the mountain lion is the deer's best friend because it keeps the population in check. That is the idea with this whole lecture. So, just to go ahead and run through a few things, you will have, obviously, there's going to be an assignment posted with this. You have until Thursday to turn into this assignment. Thursday, we will be meeting on a Google Meet, and I'm going to do a mass review. You will have your test Friday. And of course, happy news for everybody. Schools are closed till 20 for the rest of the 2019-2020 school year. I hope that everybody remains safe, and we will continue through. Adios.